Hello, today we're looking at lesson 1.3 and 1.4, day 2, and we're looking at solving equations by adding, subtracting, multiplying, and dividing, and these are specifically solving two-step equations. So throughout the entire lesson, we're going to be thinking about how we can use inverse operations in order to isolate the variable, and the check step is very important with two-step equations because there's several more places where you could make an error. So let's begin. We'll take a look at example 1a, 7c plus 6 equals 27. When isolating the variable, we always want to start with a step that is not attached to our variable term. In this case, that would be the plus 6. So we will actually subtract 6 from both sides, which is the inverse operation of addition. And that will cancel the plus 6 on the left-hand side. Now we'll be left with 7c is equal to 21. Our final step then is to divide both sides by 7 because 7 had been multiplied by c and the inverse operation is division. That isolates c on the left-hand side and 21 divided by 7 on the right leaves us with an answer of 3. So c equals 3 is our final answer. So now for the check step, we'll go back in and we'll make sure that it actually works out. So we'll start by putting the 3 in for c. So we'll rewrite the equation. This time, instead of c, we will insert the number 3. And we want to see if this is in fact true. So 7 times 3 does give us 21. And 21 plus 6 does equal 27. And so we can check that off, that did in fact work. In letter B, we have d over 3 minus 10 equals 3. Now, if you recall from the previous example, we want to get rid of whatever's not attached to our variable. So in this case, that's going to be the minus 10. So the inverse operation, again, of subtraction is addition. So this time we will add 10 to both sides of the equation. That will cancel the minus 10 on the left and leave us with d over 3 is equal to 13. Now sometimes you might look at d over 3 and say, oh, that's a fraction, that looks difficult. But actually it's really just a division problem. And so currently d is being divided by 3. So to undo division, the inverse operation is multiplication. So we will multiply both sides by 3, which isolates our d and leaves us with d is equal to 39, which is our final answer. For the check step then, we'll go through and substitute the 39 back in for d and write the rest of the problem. And then on the left, 39 divided by 3 I know is 13. And so now I have to ask myself, does 13 minus 10 equal 3? And we know, of course, that it does. And so that checks. For letter C, this time the variable's on the right side of the equation. That might look tricky, but it really doesn't change anything. We're still just trying to isolate the variable, and we're starting by asking ourselves what's currently happening to the variable. So right now it's being multiplied by 2 and then increased by 7. We want to get rid of whatever's not attached to our variable term first, which in this case will be the plus 7. So the inverse of addition is subtraction, so we will subtract 7 from both sides, and we will end up with 8 is equal to 2b. The 7's canceled on the right-hand side. My last step then is I recognize that 2 is being multiplied by b, so in order to isolate b, I will need to do the inverse operation, which is division. So I'll divide both sides by 2. The 2 will cancel on the right, and I'll end up with 4 is equal to b. If it makes you uncomfortable with the variable on the right, you could certainly rewrite it as b is equal to 4, but again, it means the same thing. So now I'll go back to my original equation in my check step. 15 is equal to 2 times 4 this time, plus 7. And from there, I would end up with 15 is equal to 8 plus 7, and so I need to determine, does 15 actually equal the sum of 8 and 7? And of course it does. The last two-step equation in example 1 is 12 equals 3y minus 9. So now I have to do the inverse operation of subtraction, which is addition. So I'm going to add 9 onto both sides. Remember, we want to get rid of whatever's not attached to the variable term first. And so that'll cancel the 9 on the right, and it'll give us 21 on the left. So 21 is equal to 3y. Now I see that y is being multiplied by 3, so my inverse operation of multiplication is division. So I will divide both sides by 3, which will isolate my variable. 21 divided by 3 is 7. Again, if you don't like the variable being on the right, you could rewrite this as y equals 7 as your final solution. For the check step, I will rewrite the equation, this time with 7 substituted in for y. And I will multiply the 3 and the 7 first to get 21. And I see that when I subtract 9 from 21, I do in fact get 12. So this checks. Next, our next example, which should say 2, I apologize. Cross that out. It says Nico took a bunch of his friends to the football game. He spent $35 on tickets and snacks. If the snacks cost $10 and each ticket to the football game costs $5, how many tickets did Nico buy? Define a variable, write, and solve an equation. So because we have to define our variable, first of all, we need to ask ourselves, what is the unknown? And usually that comes from the question that's stated previous. So it says, how many tickets did he buy? So we're going to need to identify the number of tickets. So I'm going to use the variable t for tickets. Then I need to consider what costs are going into the total here. I know that he's buying snacks and he's also buying the tickets. So I'm going to say that my snacks plus my tickets will equal the total that he spent. So if it tells us that the snacks cost $10, I know I can put 10 in for snacks. That's increased by the cost of the tickets. Now each ticket costs $5. We don't know how many he purchased, so that could be expressed by 5 times t, where each ticket is multiplied by the $5 cost. And then altogether those equal the total, which in this case we were told was $35. So now we have our equation written. The next thing we need to do is solve it. So just like in the previous examples, we want to get rid of whatever is not attached to our variable term first. So when we see that this 10 is being added, and the reason we know it's added is there's no operation in front of it, the inverse would be to subtract it from both sides. And so we're going to start by doing that. That will cancel the 10s and isolate our 5t. On the right-hand side, 35 minus 10 is 25. So now my final step is to undo the multiplication of the 5 and the t. The inverse operation of multiplication is division. So I divide both sides by 5. That will isolate my t on the left, and on the right it will give me an answer of 5. Now anytime throughout this entire school year that you're doing a word problem, your answer must have a label. In this case it's easy because our variable was defined at the very beginning, and so because we know that t was representing tickets, I will just simply write that in as my label for this answer. So t equals 5 tickets.